let folks get in. We should be live. I know a lot of people ask me why I would do something like this on a live stream versus doing an episode, but I think it's more personal. So we're going to let folks get in, and then I will get started. This is a whiteboard session, BBT style. We've had a few of these. And we'll make sure that folks say that they can hear me, and then I'll get started. So we're monitoring the chat. I have BBT Steve over here tonight, and Miss BBT will be here to watch chat and answer some questions. We'll see how the time goes. I'm going to try to keep this fixed at 1 hour. Are they saying we're good on audio?
No one said anything yet.
Okay. Make sure we're good. As we let some folks get in here too. I want to make sure that everybody can understand and hear everything appropriately.
They can hear you.
Excellent.
You're good.
All right, guys. So we're going to go ahead and get started. I'm going to try to keep this around no more than an hour. And I know, don't worry if you can't read anything. I'm going to go through all of these things and give examples, mainly around the use cases. And this today, is coming from my main part of my job, which is a principal solution architect. So I'm designing and getting through proposals for very large systems. And with that, I see a lot of different use cases for all kinds of different things from a technology standpoint. And mining and being part of the crypto space since 2010, I've seen a lot of the evolution. I've seen a lot of the stuff from the background. I've went to a lot of different conferences, talked to a lot of different people around the space, and I've always had that kind of concept as it applies to the technology side and the real, what I'd call the real, no kidding, how can I actually use this in society? Not just from the disruptive side of it, but also just how does it integrate, how does it onboard, how do companies and stuff would be looking at that. And what I wanted to go through is the different blockchain basics. And when I say blockchain, I'm talking mostly around cryptocurrency today in this whiteboard session, as applies to the blockchain tech, the distributed ledger side of it, and then some of the compute and smart contract side. There will be a whiteboard session that I'll do, really kind of cross-comparing the large entities such as like Big Blue, which would be like IBM's solutions, and how those kind of fit into the space, you know, from a private side, transaction side. And, you know, how does that integrate with the current public-facing side from like the cryptocurrency sides and all that. We'll have a separate whiteboard session for that to let people understand the differences and why companies are taking certain approaches and stuff like that, and just how does that benefit society in general, and why is that good and healthy for the ecosystem. And I want to make sure that one thing is turned off here because I keep hearing it bleeping. Sorry. And I think that'll be a good for a separate actual whiteboard session. But for this one today, we're going to first cover the blockchain basics. The blockchain, when we talk 1.0, 2.0, and 3.0, we're coming into what would be considered kind of the final phase of the block, or not the final phase, but the next phase of blockchain tech. And I'll break down the actual core functions of each of those. And then I'll give you basic use cases, real world examples of how this tech that a lot of the mining network and all that are holding up. And then you have the distributed proof of stake and proof of stake systems that also hold up that network and how that all actually functions. And the, so that's the really kind of basic breakdowns. And then I'll explain kind of mechanically how those things come together. And then we'll get into like the 4.0 basics at the very end. So if we come into the main core functions, blockchain 1.0. When I talk blockchain 1.0, I'm talking the very basic necessities of what makes a Bitcoin, Litecoin, the newest coin out there like Raven coin, stuff like that, that are the very first parts of, you know, the blockchain tech in general. And the core functions of that really come together, and I kind of classify it in kind of 4 areas. When I'm explaining it to people in a corporate kind of setting, it's the store of value, the store of state, the state of the ability to transact, and then the state of functions in general. I'm going to make sure this computer's all the way off. And the main core functions really from a store of value standpoint, when people try to go, oh, Bitcoin's going to crash, it's going to go away, it's old tech, you know, there's all these other 2.0 and 3.0 functions out there and all that. What I usually bring people back to is that store of value and the whole concept of it's limited in supply, it's you know, censorship resistance on it, meaning essentially you can try to block it, you can try to stop it, you can try to do anything and it's still going to proceed. You can try to make changes to the network and the proof of work algorithm is going to hold up the security side of it to where all you're going to do is just fork your own version of what you're trying to do. It has that censorship resistance, it has that immutability to its ledger, and it is the most powerful network out there. By far, bar none, most powerful proof of work network, there's no disputing that. So from a store of value, that gives a value, an innate value to it because there's functionality and usability there. And there's a limited resource to it. So core functions, you have a limited supply mechanic that limits the total amount of Bitcoin, and the distributed ledger based technology still there facilitating that. Then you have the store of state, where you can have asset management, you can have geographical accounting, cryptographic proofs, global agnostic to where it's at. And I'll give you a really good example that at the North American Bitcoin Conference, the Overstock CEO, Mr. Burns, came out and said, you know, one of the ways they're using Bitcoin core architecture and like currencies, like other networks that are like Bitcoin, SHA-256, using a sort of functionality that's built into it, kind of this color coins, to where you can actually store metadata. Now, why would you care about storing stuff on the Bitcoin blockchain network? When you have situations in especially third world countries where you have a situation where if you have a warlord or somebody come in there and knock out, you know, a village and move people out of that village, you could have 5 generations of people that had their property there. That's like everybody knows in the town, everybody knows in that general area that the person lived there, that's their property. They've claimed it, they've had it for, you know, 5+ generations, and then some kind of event happens where they have to exit the premise. When they're liberated or any new government, anything else comes in there, and then they come back to lay claim on that, what's actually assigning that property to them? What's the actual asset lock and management of that tech? You know, how do they know? I mean, here in the US, we have deeds, we have centralized entities that store that information. There's hedges from paying of taxes. It's distributed through its centralized systems to actually store at least a value of like who owns that. Now, I'm not going to get into the political side of like emancipation and all that kind of stuff of where you could come in and you say, you know, a government tries to take it from you and all that. But bottom line, there's centralized systems from a technology standpoint. We're just going to keep the technology hat from the functionality of what's going on. So if you can take that kind of situation and you can put a small team behind it to go out there and geographically, through latitude and longitude, lock in an actual, you know, wiki map of an area to say this is this family's properties, this is this family's assets, and you can now sign that cryptographically onto a network that's not controlled by any one government. It's out there as just a society. It's an evolution of tech, right? That's still core functionality. That's base functionality. It's built into Bitcoin. Store the metadata, put those types of accountability on there, have a system, a supporting system to the side of it that can read that data and, you know, make updates to update ownership and all that kind of stuff. That's all base built-in tech, right? You can build an entire style of tech around that, right? Just from an asset management using the 1.0 technology, which is really just posting records, posting and storage, right? Then you have the fact that it crosses borders. Then you got the state of the transaction. Again, still 1.0 technology, which is I don't want to call it the peer-to-peer, but the fact that I can submit something to somebody else and the registration of the miner network out there will validate those transactions. I don't have a third party that's keeping the source transaction. It's actually stored and written to the chain. I can make an interaction with somebody. When you have that peer-to-peer style of movement of transactional value, taxes, gambling, payment for goods, you start getting to that fungibility state. If somebody's going to accept a Bitcoin or accept another form of cryptocurrency for a good you haven't exchanged. That has been the main kind of use case that's been touted in general in the space from a currency side of saying I'm exchanging value for something. So you have that obviously functionality. Then of course it's borderless. It's a network, not something physical. It's agnostic to borders. It doesn't have the concept of borders, right? So you can have that unified side from currency. Again, we're still talking a lot of financial currency stuff because that 1.0 tech really is indoctrinated with posting information and then having an incentive mechanism built into it to perpetuate the continuance of the network, right? Like Satoshi, when a very smart person, obviously, or a collective of smart people, we all obviously don't know, came together, they figured out, one, how to do that transaction of information without a third party through cryptographic proofs, and then incentivize the network to be self-sustaining. That way you wouldn't have the natural perpetual deflationary action of the inflation kept the incentive value to where it would naturally become less of a supply, and then people would want to continue to purchase it. And that's why that's why Bitcoin, even though it's had its lows, still has a heavy amount of buyers in it. And then you got essentially the last set of state of basic functions, which is that limited data sets that I was talking about. If you want to store a family recipe forever, right? And you're like, I could put it on a cloud, I could buy this, I could put it on my own home computer, I could put it in 5 different areas, or I could write it as a Bitcoin transaction with metadata. Now it's stored out there forever. You could put actual limited amounts of information out there, sign it into a transaction, and then recall it, have that information stored out there publicly. Or encrypted into the transaction. So you have a small amount of data that you can include with that, and you could have that out there forever. So that's core functionality, core functions. We'll get into use cases here after this. I'm going to go through core functions 2 and 3, and then we'll get into the basic use cases, how it's starting to evolve, and from a solution architect side, how the why, the who cares matter of that. Core functionality 2.0 tech. 2.0 tech from the blockchain space is essentially the evolving smart contract, which is Ethereum, any of its derivative forks, Ubik, those type of networks, the 2.0 networks that really are taking smart contracts and creating a basic set of autonomous actions. In my world, I would call it, in the solution architect world, it's kind of like the business logic layer on middleware. So I can actually have a stored procedure, I can have something to say execute and then complete its action. So that going through smart contracts through an automated set of events allows you to start creating some interesting things, stuff like decentralized applications. Now they're very rudimentary right now, and I think from a corporate standpoint, people that are actually spending the R&D investment time are learning the limitations of the current set. Now this is obviously I'd call it kind of an agile based project where it's just continuous deployment, delivery, iterations, results, fixing things. But right now, the fact that you can do very rudimentary actions that are autonomous in nature to where, I don't want to pick one, I guess CryptoKitties, but as an example, where you have a functioning game, agnostic to the fact that it clogged the network for a little bit, but you have this, once you've kind of started it, it manifests and allows for its threading, and it will be self-sustaining based on the amount of effort that people put into it and invest into it, from getting their own cats on that particular piece. But if you had another application out there, and we'll get into the details of other applications you could do, you have this automated action that's kind of like acting like a middleware, but you have it in a global standpoint. Like I have these conversations with a lot of other architects, and they're like, well, I could do that in middleware. And I'm like, yeah, you could do that middleware in a company. But if I want to interact with 15 other companies literally at the same time, and then do I have to have licenses with each of them? Do I have to have that canonical document that can go across and go through interface agreements and all this other stuff? Or I could just use this network that's out there and write the basic contract that can go and touch each of these different companies literally over a few week period, and I have a functional system that all of them can interact with, and I didn't have to go through all that licensing, all that other stuff. So there's huge implications of what smart contracts, once refined and understood, can manifest, and that gives you that kind of one of the key other functionalities is the turning complete. The fact that it can go through a set of series of operations, provided it has enough fuel or compute, and it can go and complete a task. Where core functionality 1 is essentially a write, a post, and then it's there, and then you can validate it. To where this is like, I'm going to have you do a series of events, and then you're going to report back to me, or you're going to go do an action. That's the difference between the really core pieces here. And the fact that you can now interact, not necessarily to C++ level, you can actually interact with actual more higher level languages, where you can, from a point of entry for a developer, you could go in there, start writing some JavaScript, use Solidity, Serpent, LL, Triple L, which is like a Lisp language, Mutant, which is Golang. I mean, some of those are not used as much anymore, but you have this higher level where your point of entry for development is now where you can get your script guys in there and start looking at how to create smart contracts based on your own use cases. So you have this barrier of entry of development up a layer, so it allows people to work and create other pieces of that. Then you got the concept of gas in this, to where there's a consumable, right? And this is a part of a huge debate, especially between the 2.0 and the 3.0 tech, of saying that, well, cool story, however, I don't want to have to just continuously feed my app fuel, and that's part of the sales pitch in general for the 3.0 tech, is the divergence of having to pay for the computational side of it, right? So, I mean, we'll see how this manifests, because it's not there yet, but it's this concept of gas is that you just won't run amok and just be this process that just keeps running and using up resources. It's going to run out of gas, and it's going to stop, because you're going to feel it only so much. So you could contextualize your functionality within a certain amount of, give it enough gas to let it run for so long, right? So you can have that kind of issue. There's issues that are found from that, and that people are working through, to where you can have, if the network has a lot of traffic and activity, because you're all essentially sharing the same network. Think of it like you're all potentially millions of people sharing the same computer. From that network side, that for your transactions to execute, you're spending more money, essentially, because you want to be the next in the processing. So you have this scalable issue that some of the future tech that Ethereum's working on, as an example for Ethereum being core 2.0 tech, is the ability to have kind of that lightning network, and we'll get into the details of like Bitcoin stuff on that, but have that kind of next evolution of not having to spend so many resources to make the compute work, right? So there's some tech that they're working on to modify the way that gas works and its processing. So again, added a new piece of functionality versus the core functionality. Then you have, I put the solution architect hat back on. I look at a lot of that as that BPMN activity. So if I'm going to map out a process, I can look at that from a business processes management piece, and I lay out all the little steps, who the roles are, who needs to interact with it, who needs to trigger certain things, who can see the information, who can't, who else do I have to interact with, so the who, what, when, where, how, and why, right? So I lay that out, and I can lay out an entire business process out there. A lot of those business processes we could write into a smart contract, right? And then that smart contract would run, and it'll be self-sustaining, because I'm just going to be feeding it some fuel, right? So versus I would have to have a logic server set up, I have to use a whole bunch of compute, maybe have a Hadoop database structure, something that is bringing the business logic to the data. I could have all that into a smart contract and not have to worry about it, the maintenance of it and all that kind of stuff. It's autonomous. So, not necessarily replacing, but maybe augmenting some of the features of something like, the middleware world. That's really where the smart contracts can really come into. And then having the oracles, which are systems that sit outside. And you have all this cool tech, you have this automation that's now potentially saving lots of cycles of developer time, because you can make a few contracts out there, copy them, change some settings, and then have this automated process. But I'm still going to need systems of record data. I'm still going to need all these different data interaction points. So these oracles are set up to now interact with that contract. So the development of these to be able to interact with systems of record, you know, these are things that as the tech matures, entire companies and newfound, you know, startups will find that as a good opportunity to take some of those large, huge, known data sources, zip codes, addresses, airline times, all these things that are kind of readily available. There's APIs out there, but taking those and getting those into a function to where you can start pulling those into some of these smart contract systems and being able to now have your data sources. You know, so the Oracle development of, you know, the world's, I would call it the knowledge, you know, that kind of stuff, that and the real-time nature of the way data works, being able to pull those into the smart core, you know, functionality, that kind of development right now in core functions. And then now you got like the 3.0, which is now coming out, which is again smart contracts but kind of evolved, taking this concept of gas and kind of separating it, so you have the runtime, so the application that needs to actually compute in that, and then having that versus like the identity portions of it kind of pulled apart. So the best way to explain this is as people started to evolve this tech and they wanted to say, I only wanted so much information being seen. Like if I order something on Amazon and UPS is going to ship it, and I'm paying with this other source, I have 3 kind of entities that are interacting in different ways. I don't need to necessarily send all that information to UPS to deliver it to me. They only need a certain bit of information. So being able to segregate and layer the networks now, you have a kind of everything bundled into a transaction in core. You have core 2 can now take those transactions and kind of separate them into executable units and automation, but now I need the size of pie sliced. I need only certain entities to interact with certain points of it. Security, identity, package of information, the metadata, maybe just the header information, all that kind of stuff I need to now separate into layers, but I need to keep it together to when I need to execute it. So you start looking at this 3.0 to how to separate the contract layers, the people that really need to know, you know. And this is kind of the software evolution of just normal things, like as people start to figure out when they start to write an application, like, oh man, I only want so many people to see this, and I don't want people to do this, and then you start getting into these business rules that are more complex. Well, when you start looking at the tech here of what can those do, some of those complex tasks or not, what do I have to make changes to? So when you have core, the core functionality is at 3.0, which really what I'm talking about is like EOS, is what EOS is trying to bring, and Cardano, ADA, those, potentially Neo. I haven't done a lot of research on Neo, but EOS and Cardano really kind of, at least from a white paper standpoint, kind of saying and claiming this is what they're wanting to do. And then you have EOS with a testnet trying to prove it out, right? So this stuff's not all the way there. You got ultra fast transactions where you're limited on transaction speeds here. You have a concept of lots of transaction speeds in Core 3.0. So it's something that's really hyper fast. So if you think, or I'm going to be doing rudimentary contracts here, order of execution, and we'll go through the examples here. So I'm talking around it right now because I'm going to get into the basics of it when we're actually going to peel back a use case, and I'll explain how those kind of intertie together. But the reason for high-speed transactions, and then IPFS storage, which is interplanetary file system storage, where I have the compute, I have the logic, and now I need the storage. I need to put stuff somewhere. You know, if there's lots of data, there's results of that data, I need to put it somewhere. You know, if it's an image data, is it structured? Structured would be like an Excel sheet, right? I have columns, right? And I have rational data. I understand. It's like, you know, if I was looking at just a like my address, my name, all that kind of stuff is, you know, address 1, address 2, city, state, all that kind of stuff that's structured. And then you have non-structured data, which that you need to store. Pictures, images, how does that relate to that address, right? That kind of stuff, non-structured stuff. So having that kind of data in a storage mechanism, that I'm not having to go rent a lot of storage. How can I store that in the blockchain itself, you know, without bloating it out? You know, I want it purpose built. I don't want to just store metadata that starts filling up all of the block sizes because I'm just storing a whole bunch of data in there, right? I want a function that is that, hey, you, for this task, I need you to actually store data, and then there's a compensation methodology that's built into that. You know, stuff like StorageJ and Litecoin, that kind of stuff that have storage contracts, of augmenting that tech into the application layer, and then I have somewhere to store it on these, you know, using the blockchain tech. So then you got, you know, the Web, I call it the Web 3.0, the kind of new internet is what it's being touted, to where you have kind of the infrastructure as a service in general. So you have the whole concept of, you know, routing and protocol tables and Internet of Thing devices where you have machine to machine, like smart contracts to say, you know, my camera can only interact with my router, and it creates a relationship. That's just not I would call it a binary relationship right now, to where right now on TCP/IP it's going to connect because it knows to connect to a device to get it to the internet. But that whole certificate and exchange to say, is that valid? Is that still the device I should be connected to? Or can I get redirected to connect to something else? So that layer of security, that layer of that smart contract that is immutable and can't be updated because the right setting's not turned on. That's the kind of evolution of that. That's the stuff of why it's so powerful for something like Internet of Things when you start tying blockchain immutability, scalability, and the security of it, of not having like a write and update. And if it was updated or it was something was done, I have a transactional hash to validate it, saying, oh, well, our local security was impacted. Somebody got onto the computer that could write to the smart contract and sign the transaction to update the Internet of Thing device, right? That's what I'm talking about, is that kind of where you're not going to have an outside person coming in. It's going to, it changes the potential, potentially it changes the security of it to a whole other level. So that's where you start looking at the tech of Core 3.0, leveraging the existing technology, having the storage and compute, and then having the transaction speed to do really modern high-speed things. And then getting into, identity contracts I had on there too from a Core 3. So that was kind of the main kind of evolution, where you had just basic state and store value, transfer stuff, smart contracts, enhanced smart contracts with lots more speed, layering of the tech, right? So those are kind of the three phases. There is a fourth one here that I'll briefly talk about, which is kind of the evolution of this 3.0 to really 4.0, which we'll start to see probably in the next year and a half, where you're talking distributed computing. I talk about it for the past like 9 months on my channel when I see the potential when it comes to the distributed computing that we do from the mining side of using GPUs to do proof of work. Having those GPUs retasked to do something like a proof of effort or a computational function, which is the way like computational fluid dynamics or some kind of stored compute that you need to do and you need to run numbers essentially on, having the smart contract distribute out compute requirements. So if I have to go, I'm a weather station and I need to run real-time numbers that are faster than what the weather service is giving me, I want to run my own computational thing based on the sensors that I have, and I want to see what is the prediction models there, and I need a lot of compute power. Well, technically, as these dApps, these decentralized applications are formed, they could start to utilize the existing mining network. Stuff like that, to say, you know, a CUDA core is a CUDA core is a CUDA core, which is part of the NVIDIA clusters, that I could actually offset people, because there's a lot of technology out there for that people have invested in the grassroots, from 1 or 2 mining systems to huge farms of mining systems that you hear about all the time, holding up Bitcoin networks and Ethereum networks and all that. Those getting repurposed to actually do general compute requirements and actually run the virtual machines and doing all that on these actual, because there's a lot of computational power. So that's the 4.0. So where you bring we've talked about kind of like cloud kind of storage, we've talked about the logic storage with all the automation that's being built into these smart contracts, and then you're looking at the compute side really coming into that 4.0 tech. That's the Golem, which is one of the Ethereum ICO projects that has raised money to try to answer that world supercomputer kind of concept. So that's the 4.0, serialized parallel computing, distributed computing, that kind of software rendering, that kind of stuff, really coming into 4.0, really coming through 2018 into 2019, that tech really basing on the logic and the structures that are supported by the 3.0. So I'm going to change gears. I know I'm going fast. Thank God you guys can rewind this after.
You're a half hour.
I'm at a half hour? Good, so I'm in good timing. So we get into the basic 1.0. So what I'm going to do now is I kind of explain the core tech of what makes it up, the features. Now I'm going to get into the basic 1.0, basic 2.0, and basic 3.0 into use cases. Actually how mechanically these things come together. So the basic 1.0, the so what factor is it's the distributed ledger. You guys have probably heard us 100 times of what it is, and if depending on what level you guys are at on just blockchain in general, distributed ledger, debit, credit, the accounting features. I have 100, I do a minus 50, it returns me back to 50. I have 50, that's stored on the distributed ledger. It's a ledger of activity. It's immutable. It's out there. Nobody can go and update it. It's just myself and anybody that has access to those private keys, right? Public key cryptography and balances that out to make it function, right? That's the main core piece of it. You have the proof of work security. Why that matters is it makes it very, very exceptionally hard for somebody to go out there and change anything. Like impossibly hard right now with the current tech, where if you try to go out there and attack the network, all you're going to end up doing is probably forking the network and just having a copy of it. So you're not able to go out there and adjust it, and that's super powerful. I mean, from a whole bunch of reasons. So having that distributed ledger tech, limited in the supply, you have this natural effect where it has this natural effect to grow in value if people believe in it, right? It's very speculative in nature, but when the realities of the functionality and people see that functionality coming into play as finance companies are investing in it, you have your use cases of exchange of value, exchange of information, because you can actually store that information that I was talking about with addresses, information, stuff like that matters to people over the long haul. You can buy it for goods and services, personal ownership. Nobody can take it from you, right? Well, relatively speaking. I mean, if somebody like attacks you, pins you down, and I think there was a couple of use cases where people had their private keys stolen, but it was forced out of them type of thing. You still have that kind of thing. It's kind of like cash in that perspective, where you have the cash in your pocket. Nobody's going to tax that unless you have to go pay it, right? So it's kind of like a digital cash in that perspective, but it has its use cases. It's also having I put in here the evolution of lightning channels and segregated witness, the tech of fixing certain mechanics with the way cryptography works, where you have this transaction malleability, to where technically if you did a transaction, somebody could go in there and use these techniques to modify some of those transaction details. They could leverage the existing tech to manipulate it. So you had enhancements with segregated witness. That also helps with the transactional nature, where you kind of get into this bar tab transaction style, where where each transaction was costing all these fees, and people are like, this kind of sucks. I don't want to have to post each time I'm making a transaction. So I want to do this bar tab type of transaction system, to where it's like I go to a bar with my friends, I'm going to open a tab up, and I'm going to make 50 transactions that night, if it's a good night, right? And have 50 different beers, and then I'm going to make one post transaction to my credit card at that time. So using that kind of tech, where you have a bar tab transaction thing, where you could queue up a batch and then post a batch, kind of helps save the whole network from just having constant transactions, right? So lightning channels being able to set up where you have kind of like debit cards from different companies set up to where they can now exchange with each other, and then you start creating this mesh network of different actors that'll start being able to trade at very low cost. So you got evolution going on in that 1.0 space in general, enhancing the financial functions of it. Then you get into the 2.0, the basic use cases. This one I'll probably spend the most time on, and I'll finish up in 3.0 because there's not a lot. This is a lot of theory right here, right now. But the 2.0, essentially I did a basic mock-up of how this system kind of works. You have a basic business app, you have an Ethereum private node locally, and then you go out and update the Ethereum network. So you have a submit transaction, a query the state from the app. You sign and unlock the account to make the transactions out. You broadcast it, and you sync the state of that transaction. So all that in English means that if I have an existing application, or I'm trying to build an application as a decentralized application to do a set of functions, that I can go out there, build that in-house, and then go sign those transactions to the rest of the network. You know, pretty simply, and then have the, the basic, then this was from a Medium article. I want to make sure I quote some of my sources. Obviously, the 8 years that I've been doing this, 7.5 years in this space, a lot of this is just a share of information, understanding how it functions and works. This particular diagram came from a Medium article that I saw, and just how I personally looked at spinning up an ARM template, looking at how, and that's the Microsoft Ethereum Foundation in Azure Cloud, actual spinning up a little node, setting up a small automated contract, and seeing how it interacts and transacts, right? Of how would I build an application, how would I broadcast it to the public Ethereum network, how would that matter to another company? When we look at the use cases for that, this is the stuff that gets everybody kind of excited from it. Because you look at the whole concept of this is, I'm going to have a network that is being stilted up. Right now, a mining network. So if this thing's holding up this bridge, this is the miner network that's being compensated for holding that platform up. That's the same thing with Bitcoin. Bitcoin's the same kind of basic concept. Miners holding up a platform that I'm going to transact like a train car to do things on. They are compensated for holding up the train tracks. And when I want to use that train track, I pay transaction fee, right? So you got a network that's already there. This is normally, in the compute world, like on a cloud standpoint, this is Microsoft, this is Microsoft Azure, this is AWS. This is the platform, right? This is what holds it up. I go build in a smart application that's maybe a train car, and I want to send that somewhere for a response. I'm going to pay the transaction fee of that thing moving based on size, based on how much storage I'm using, all that kind of stuff. And then they're paid an incremental fee for that action, but I am transferring value now, information, execution of something. I'm doing all that on that platform that's being hosted up by all the miners. And as people start to get rid of this kind of layer to say, I don't want the mining network, I want to have this distributed stake thing, this proof of stake, to say I'm just going to stake coins, and the rudimentary actions of validations is going to be handled by the stakeholders. You have this consolidation standpoint where you don't need as many, you don't have that huge distribution of miners, but you have all these stakeholders that are doing the same thing. By and large, it works for, it works for Dash, but it works for a couple other ones, but they're all using kind of a hybrid. Now I could go through a whole other background of the proof of work and why it's important versus proof of stake, but for the basis of this, I'll just explain that the network is being held up, and it's global. And if you're building an application such as a supply chain, medical records, power distribution, all that kind of stuff, all of that is being held up through this network. So then if I'm going to make the investment to build, I'll use the health records as an example. If you're a traveling student from, let's say, China, and you're here in the US, and you have all your medical records in China, right now, you have an event. If you go to a hospital, you have this event where you got to make a call, you got to try to get the records, nobody knows. What if they don't know you? What if you don't speak English very well? You have this whole issue here to where they have to go back and try to get records, which are not easily released necessarily from that country, and you don't know anything about them. You don't know what's going on. You want to get information to it. So if you had essentially a basic public health registry with an agreed upon set of agreed upon set of variables, and this is, I'm talking minimal set. I'm not talking taking the entire blockchain and trying to replace your entire healthcare system. I'm saying take one piece of use cases of creating a single form that shows a person's name, ability to transact with who they are. Now we have social security numbers, but just this kind of global, here's my ID on this health network, and then here's the basic things I'm allergic to, here's where, some potential issues I had, just the header information of the issues that you've had throughout your life, right? If you had an accident and you had a gallbladder replaced, just the text, the top level. something that a doctor's going to look at and go, check, check, check. Okay, don't touch that. Don't give them that. Great. One form. That's how powerful this is. Is that if I was to try to do that kind of form with that kind of information with everybody in the world, right? Think of the logistical nightmare of trying to correlate all the different companies and all the different stuff to try to get all that information in a singular source. To where if I built a network, or I built a form first with the basis of information, and then I gave a standard to say, hey, all you companies out here, subscribe to this standard. Report your information on this global smart contract. You know, you have this global smart contract that would actually store all that and execute that. And you'd have this signing pair. Let's say it's part of your issued out medical cards that would have its smart contract ID, right? That gave you the private key connection, like a common access card, something that has an actual chip in it, something that the medical companies that are out there are getting, that are subscribed to this, issue you out a paired private key where you have your private key paired with the insurance and you that's interacting with this Ethereum smart contract that all the hospitals are feeding up to just a portion of the information. Now you have this pretty simple single form set of information with your ID tied to the rest of your, you know, they're not going to get to your insurance history and your payments or any of that kind of stuff because you have that layered kind of setup, right? You have this potential to where it's one single standard network across the board.
We tried that earlier, Christy.
Sorry guys, I don't know what's
in the picture.
Oh,
Someone wants to see it.
Oh, okay.
Glare.
I'm like,
oh, is the glare there?
bad.
Yeah, sorry guys. Yeah, I could. I mean, you really can't see it. It's kind of a mess here. We'll take a picture of this whole thing in high resolution, and I'll post it up on Twitter for you guys.
They already have.
Yep, and then that way you guys can see it, kind of how this functions. So you have that kind of situation to where you can have a smart contract standard, and mind you, this could be a small company right now. This might be a freebie for one of you small companies out there, or small entrepreneurs to think, I'm going to build a standard. I'm going to publish it as an Ethereum smart contract, and I'm going to provide an API or a WSDL to hit that information to where now you can upload it to me. And here's how I'm going to protect your data. Here's how they interact, on-ramp, on-ramp. Here's how those things are going to interact. And now you can start getting that out to companies. Get it out to one insurance company to produce the cards, to have that smart contract, to where then people can start getting their information. And you have this huge network that's being held up by all the mining network or distributed proof of stake network, and then it just functions. I log into, you know, my browser and I have MetaMask in there and it's connected to the Ethereum network and I can go make transactions, I can do all that stuff. So you have this functional platform that you can build these apps on. That's the power of it, is that if I wanted to synchronize functions, I wanted to synchronize, you know, a supply chain between multiple vendors, producers. So you have, in most supply chains, you have the person that's extracting raw material. They form small raw material into base materials that companies buy base materials and form into different objects and things and stuff. And then those get turned into a company that's going to buy parts of their assets to form something else. So you're looking through this like 8-10 step process just to get to like maybe a circuit board. So the raw extraction, all that stuff, to where you have all of those different elements, the batch numbers of lithium, the batch numbers of aluminum that gets formed into things, that goes into other objects, that then gets into the main supply chain to Samsung that starts to build a phone. And who built the phone? Then that goes into a shipping company that takes it overseas and then distributes it to everywhere. All of those various steps throughout that entire process down to the guy that's actually mining the actual materials, all of that stuff can be stamped in this transactional nature, and all it comes down to is why all that stuff sounds like way pie in the sky idea. It's not all that hard because it's actually being done right now. And all the companies that are involved in that have systems. And ironically, most of them have Microsoft, or they'll have Oracle, they'll have all these other things. right? And they all kind of stacked up, but they have different versions of stuff. And when they want to interact, they cross these domains of like commercial portals and all these different web portals that exchange information and transform things. And there's some standards and some non-standards, right? So where you have this huge web network of stuff that if I'm this guy in the end and I want to know where did this part come from, it's amazingly hard sometimes to find. And it's not just amazingly hard from a technology standpoint. I might not have a license agreement. I may not have a direct interaction with those people. I had no idea they were part of the supply chain. All of that kind of stuff occurs in this, to where if you have now a platform that's, I don't have to worry about the holding up of it more than the one or two dApps that are on there, that now as a company, I'm going to come over here and I'm going to subscribe to that dApp. It changes everything. I'm going to give you one more example and then we'll move on to the last one and then we'll wrap this one up. In this, here's another freebie for the world. We have about 10 minutes. Yeah, I'm trying to keep this to about an hour. Here's another freebie. Let's say another one of these startup companies wanted to do a single source privacy selector. Let's say you built a smartphone app. And on there you had all the basic privacy things that you care about as a person, right? Do I want them to have certain information? Do I want them to know my address? Do I want them to be able to contact me? All this kind of stuff. You have this global, let's call it global privacy settings. And then that app would publish to all, let's just say social media sites. Because let's say they had a privacy adapter API here, and I could build a smart contract on a phone, go through and execute, and then push this to all companies. Or they had the option to pull it from my update. Right? Let's say they didn't want to interact with me directly, that I went to this privacy app, to this repository of information by people that had that pair, that key pair, because I've signed an API agreement with Facebook that I want to give other companies access to my information. Whenever you go and say, oh, I want to try this new cool thing out on Facebook, and it says allow, and it's giving you access, you're essentially giving them API access to specific parts of your information. Well, what if that API information is privacy piece? And then you said, you know what? I want you to inherit all of the settings I have from this one app. And now the full symmetry across your entire social platform is now updated based on one set of settings versus you going to each one and trying to figure it out across all of them. Now you're probably thinking, oh, well, why do the companies want to do that? Where it's at is the information. So if you can have this information of privacy stuff, and then maybe incentivize it by giving one or two things saying, but here's what I'm interested in, and I will only unlock part of that for those particular things. I call it the carrot, right? It's given a little carrot of exchange. It all comes down to exchange. And right now, a lot of the exchange in value is where we didn't give it, essentially. It was kind of, I don't want to call it taken, but it was like we didn't realize that some of the stuff that was being captured is being captured. What happened? I don't know what's going on with the line. So you have that situation where now you're going to incentivize all these networks to go out there and take that information. And all this is being hosted up in a smart contract. Why it matters is like people that are probably following that are programmers or developers are like, well, I could do that in you know, a simple stored procedure in whatever system, name whatever open source or whatever system you want to say. What I'm saying is that what if that's a smart contract on Ethereum and it's like, you want to go interact with that? Go interact with this smart contract. Here's the details on how to interact with it. It's global. Not licensed. I don't have to mess with any of it. I can write that smart contract and then people can choose to interact with it or not. That's the power of using a platform-based global system that's being held up with its incentive already in check. And you got all of these different, you got power distribution, you got all these different supply chain, different sub-use cases that are going into making up the power of that smart contract to interact with companies. And then finally, I'll end with the basics on EOS, Cardano, IOTA. Really from all these use cases, is taking these, where a lot of these were rudimentary actions. Everything I just talked about, the healthcare piece, this privacy thing, were single trigger settings. They were 8 to 10 variables on a particular identity, right? So if you had in a database world, it's like you're the user, you're this ID, and you have these 8 options. This is me, and then the 8 options I want you to choose. So very simple smart contract setup there. But if I want high volume transactional data, I want real-time updates, I want trade history on everybody in the real time, or I want all that data for myself. I want flight schedules, I want all this stuff that's going to be very quick transactions, require compute time. Then I'm going to need something that's not just very rudimentary contract automation. I need something that's more real time, can be compiled, has asynchronous transactions. The fast platform has that IPFS where I can store lots of data on it. Like if I wanted to take that healthcare scenario and now I wanted to include like not just the action, that single title to say this person broke their leg when they were 9 years old, that I actually have the the different image data that comes with that to where the doctor can actually see the break, that kind of stuff. That's where you could first implement on something like Ethereum with that basis. You could augment it with something like EOS to where you could have all the storage data there. So then you can have all that correlated information now with depth, and that you have the storage and the speed to be able to project it, right? Then you have the mobile, mobile apps, high availability network. That's the other piece of it, and that's the other piece on most of all of this is the high availability of the network. Is that it's distributed. You're not going to have 1 or 2 systems down and it's all down. Is the ability to kind of answer the call, and where like Ethereum was clogged with CryptoKitties, that you have this high availability network that you're not going to have with latency and heavy timing. Now a lot of that sounds great in theory, and it isn't. It's in the testnet now, so it hasn't been proven out. So it's just a lot of words right now. So let's see. I like all the words that they're saying, but I want to see it. I'm near the show me state, which you don't prove it to me, but and then that separation of the layered separation between the settlement layers and the identity layers and all that kind of stuff, where you can have the groups and you have the separation of the data. So that's really kind of that. Use cases, obviously, full applications, protocol like TCP/IP, information as a service, all that kind of, or infrastructure as a service. That kind of tech is really the use cases for that, where you can have more robust platforms. So it's like a beefed up version of Ethereum's kind of network, to where you can have more robust applications, running compute, running storage. That's really the main core pieces of that. So it was a lot. It was an hour-ish, 7 minutes. I'll take a few questions here at the end.
Somebody said, "What is cryptocurrency?"
What is cryptocurrency? You can go back to the beginning.
It's in the title.
I had that in the beginning.
They said this should be Crypto University.
Crypto University. Well, I get asked a lot for this kind of stuff, and I mean, my day job is to build these systems, like big systems up here, and explain to people on how it's going to function, how it's going to work, what technologies we can use, what cadence are we going to do to get there to the end, that kind of stuff. So as it's starting to now bridge that gap with this tech getting mature enough to actually implement it, I felt it was due to kind of like show people the separation of the space from at least one architect's point of view. Any other questions before you?
Gangsta says he's dizzy.
Yeah.
Gangsta says he's dizzy.
He's dizzy. Did I go through it pretty quick? All right, guys. If we don't have any questions on Twitch.
Do you think that the smart contract crypto is just going to end up being thousands of forks for each group that wants to use it?
So I think from a public side, if there's forks, it's probably financially driven because people are trying to make money, honestly. I'm just being honest about it. Unless they have a distinct purpose and they're trying to answer something that they're not getting a response on the main net of whatever coin they're on. So like Ethereum, and you look at the Ubik forked Ethereum, and then what their mantra is that they're going to take all the EIPs, the Ethereum improvement plans that made sense for a business context, and they're just going to implement those. That they're not going to focus on anything but that kind of tech. So you can have forks and derivatives of the current currencies that are trying to implement specific types of functions and features. We had the split with Bitcoin. Bitcoin Cash wanted larger blocks. Now there could be a whole bunch of sinister other things that people bring up, but I try to look at it from just the technology. What was accomplished in that? They fork the network and they have a larger block size. That's essentially, I mean, there's a few other retargeting with difficulty and stuff like that from the usability and functionality of the supporting of the platform. But by and large, it was just a block size increase, and they can stuff more information in the block. I think people will continue to fork coins that feel like that. But if you're looking for global standards for business, they're going to look for something that's stable, that is showing improvement, and then eventually having the scalability that's going to be required to do a lot of the stuff that I was just saying with like the supply chain side, because that's the most, that business logic layer is the real long-term use case. And then the protection of the immutability, because the other part's the immutability of it. That's one of the biggest sales pieces. At least that's what I would go in a lot with any kind of architecture stuff that I go in, is the fact that if I'm not doing anything more than just writing an immutable transaction of saying this is what's occurred, this is the state of this, and I know that it's not in a centralized database that can be modified and updated, right? And there's security measures and there's certificates and things that can be applied in a centralized capacity to guarantee the immutability of records per se, right? That will leave a trace if they try to update stuff. But that being said, that's still all a centralized solution. It's not a global solution, right? So in those use cases that require my interaction from a business to a business to business to government to businesses to other businesses around the world, I can try to use public internet with centralized types of systems, and we do every day. But there's starting to, when it's hard for us to create all these kind of VLANs and all these other different connections and stuff, and I'm like, why don't I just use a blockchain and make a simple smart contract to transact the information kind of above state and then back down, and now I can deleverage some of that effort now to a public facing network and have that separation that I need from an encryption level and the detail level to where I can still show the public transaction, the fact that something occurred. It's like I put in a train car on a track, and on the transaction side, it's the start and the end, essentially the train crossing the track, going across the track. And you can know the dimensions of the box, and you know that it's so long and it can length, width, weight, height. You know what the box dimensions are, and the start and the end when it got to its destination. But the contents inside are encrypted and stored, right? So you don't know what's inside the box. But now I want to get it from company to company. That's the way I like to explain it to people, and that if I'm using that public network with the right levels of security, with the right levels of contract, the smart contract set up to where I want to encode the details of it, have information that is not structured for people to understand on the outside of it, because I'm trying to correlate it back to some internal database. I can still use that transport mechanism to have that train car run that track and not have to have some big global compute set up configured.
So how long till you think these kinds of systems and contracts and such become mainstream, commonplace?
They're starting to become mainstream now. There's functionality getting put in place literally every week in the past 7 months, 6 months, you've seen and heard of some company now starting to test bed it or doing it with a small bit of information. There's I know there's UAE government's done some stuff with it. There's stuff down in London when it comes to property stuff. The Swedish asset management companies doing stuff with it on the Bitcoin blockchain. There's companies that are actually using it as part of their business plan, as part of what they're storing information. The real breakthrough is going to be when a standard is accomplished, when a smart contract for healthcare or a smart contract for asset management on a much larger scale starts to becoming the standards where all the companies, it's not going to be from a single company trying to do it with another single company, that it becomes a standard that people start writing to. I think the big players such as Walmart and some of the big commercial players that are actually going to, and that are investing the time right now to build that out, are in the works right now. So, I mean, this isn't something that's going to go away. And understand that everything I said today is not necessarily correlated at any point to the price right now. You have essentially the makers and the users, and then the pricing side, taker side is like the it's completely non-correlated and speculative compared to this, right? Like, and that's the whole thing. Is like when I'm talking in architectural meetings, nobody talks about the price, right? Price is a different beast in itself, right? But the functionality, all I would say is that if standards and things were set up on this functionality and people start to subscribe and project to it, that the speculative nature of things is going to be like, holy crap, the CDC and everybody in the world's using this for this function, is probably going to speculate the price up. I mean, that's just my guess on it. So price, functionality, and then mining network are three completely different entities that all support it in some fashion, but are not necessarily correlated with each other. I'll do one more question and we'll end it.
What do you think about countries creating their own cryptocurrency? Like Sweden is looking into doing that right now.
Well, Sweden, Petro from Venezuela. I would be. I mean, if they're gonna, it's all how they back. You know what they're saying. So like Venezuela is claiming that they're backing it with oil. You have Sweden. I don't know what they're going to try to back it with, but it's an interesting. I think people are kind of ICO shocked, where there's been so much just increase and then decrease in it right now. I think people are kind of neutral on if that price is going to do anything with these country-backed currencies. It really comes down to if Sweden made a currency and then mandated that said currency was tenable at all locations in their country, then you're going to have a functionality use case that now will have at least some kind of metrics you can drive to how many people are using it. What's different than like using Visa with that particular scenario. The things that give Bitcoin and these other cryptocurrencies value is not just because of one country. It's because of a world using it, a world believing in it. Part of it is that libertarian side of like there's no control of it, that you can't shut it down. Those kind of things, I think, augment some of its value. And then you have other financial instruments that come in and see the power of it over the last 8 and 9 years and have built other infrastructure around it and now can speculate price from like the CFTC. So again, all world currency. Is the CFTC going to speculate pricing on Swedish, whatever they're going to call it? I mean, who knows? I think that at the end of the day, it's a roundabout way of saying that I don't see it any different than any of the other coins, with the caveat that it's just a government saying that it's theirs. It would probably get speculated just like anything else. There's no competitive advantage really at all with it. Financially anyways. All right, guys, we're going to try to wrap this one up. If you guys like this, please put your comments below. I try to keep it kind of high level. We could possibly go a deeper level on like a Twitch stream or something sometime, and I could just have the whiteboard behind me. If you haven't followed us on Twitch, follow me on Twitch. I open up sometimes these live streams for like 3 hours, and I just kind of go through stuff, and we can kind of hit stuff back and forth. Again, I always try to make sure that this stuff is out there free for you guys. I know somebody's probably going to take this and probably try to make a Udemy class about it. I mean, that just happens. So if you see it, you can say, wait a minute, that looks vaguely familiar. But hopefully it was value for you guys and give you guys some kind of insight on the tech. Like, subscribe, share if you liked it, and we'll catch you guys on the next one. Yeah, it's in there.